Ball A traveling with speed v in the direction shown makes a glancing collision with another ball B of the same mass. After collision, the balls move off with speeds VA and VB in the directions shown. Which of the following is true? So, since it's about a collision, we know that there is a low conservation of momentum, and these two balls can be considered as a closed system, and low conservation of momentum says that for isolated system total momentum is conserved, but momentum is a vector quantity, so mv before is equal to a vector sum of all mv before is equal to the sum of all mv after, and directions must be taken into account. Total momentum before is equal to total momentum after, but momentum is a vector quantity, and it should be conserved if we consider in any direction. So total momentum before should be equal to total momentum after if we consider in projection or in components onto any direction, and we can consider horizontal direction, let it be x, and vertical direction, let it be y. And I repeat that momentum should be conserved in any or in projection onto any direction. And if we consider vertical direction in vertical components or in projection on y-axis, total momentum before it's let's mass be m, so total momentum is mv, and total momentum it's plus, and total momentum after it's component of this momentum on y-axis, and component you can see that it's this vector, and component is this, it's sine, so it's mva sine of alpha, or this vector is va and you need this component. It's the same as this, and this angle is alpha, hypotenuse it's va, and you can see that you need the opposite leg, so it's hypotenuse multiplied by sine, and it's in this direction, so it's plus, and plus mvb also sine beta. It's low conservation of momentum in projection on y-axis. You can see that m cancels because mass is the same, and about sine, no, see is not true. And if we consider projection on x-axis initially, or total momentum before, in projection on the x-axis is 0, because vector is perpendicular to x-axis and its component is 0. So initially horizontal component of momentum or total momentum and horizontal component is 0, and after it's VB, and horizontal component is VB cosine of beta, and minus, because it's in opposite direction to x-axis, VA cosine alpha. M cancels, and you can see VA cosine alpha is equal to VB cosine beta. So A is correct. And that's all for this question.